LeCTURE-1.
Okay, students, today we are going to start a new topic and for board exams, this is the highest scoring chapter. Okay, for entrance examination, aldehyde and ketone, and for board exams, this is the highest scoring chapter. Okay, so but most of the things what we are going to study over here, what we are going to study over here will be directly from the aldehyde and ketones also. Okay, so this chapter is interrelated to carboxylic acid and derivative are more interrelated to aldehydes are more interrelated to aldehydes and ketones. Okay, so if you wanted to score good marks in the carboxylic acid, let it be in the competition way or in the board exam, but you should have basics from the aldehyde and ketone. That's why they are commonly called as a carbonyl compound. Okay, carbonyl compound, understood? So that is what the carbonyl compounds means, because it contains C double bond O group. Any substance which have this group are called as a carbonyl compound. But after that, if you write OH, then it is called as a carboxylic acid. So it is a part of the carbonyl compound. Carboxylic acids are part of the carbonyl compound only. Understood? Only thing they have some extra fitting. What is that fitting? OH. Okay. So when you add in place of the hydrogen, see, if you take it as a hydrogen, then it will be aldehyde. If I introduce one oxygen here, then it will become as a carboxylic acid. Okay, so that carboxylic acid and aldehyde, that is the difference. Okay, and in the ketone, this should be completely removed and OH must be added, then it will become as a carboxylic acid. Okay, so it is a homologous of the carboxylic carbonyl compounds only. This is what we are going to study in this lecture. Understood? So I hope all of you have gone through the every lecture of aldehyde and ketone. Okay. We have done previous year questions of aldehyde and ketone also. And there is a special lecture for the uh, aldol condensation, and there is a special lecture for the Cannizzaro reaction. Okay, Cannizzaro reaction. So these are very important topics of the aldehyde and ketone. If not gone through that, or if you want good scoring, then at least Cannizzaro you must. Okay, so that you can score, your score can be improved, and you will understand the carboxylic acid also easily. Understood? So let's go on to the first slide. Okay, up to here I think it is everybody clear what is our plan and what we are going to do. Okay, so let's start with the first slide. Okay, here is the general introduction. Okay, first of all, why carboxylic acid is so complicated? Complicated just are acidic in nature. Okay, question will be why carboxylic acids are acidic in nature. Okay, once we say it is a acid, once we say it is acid, it should be able to lose hydrogen. What it should do? It should be able to lose H plus. Okay, so after losing the H plus, if it is stable, then it will lose. Is it understood? After losing the H plus, if it is stable, then it will lose. Otherwise, why it will lose? Okay. So suppose this is the carboxylic acid. Okay. RC double bond OH. And the question will be structure also. Okay. That structure I will tell you in the next slide. So with the hybridization and all, I will tell you in the next slide. Okay. So for the time being, organic compound containing COOH group are called as a carboxylic acid, and carboxylic first was given by the scientist Bayer. Bayer is very important. Bayer reagent also there. Okay. And it is a resonance hybrid structure of carboxylic acid group. This is the resonance hybrid. Okay. Now see here. If it loses H plus, then there will be minus charge. Okay. Now on the minus charge, there will be shifting of the electron. There will be shifting of electron. That means even though carboxylic acid loses H plus, the remaining part it is called as a carboxylate ion. What it is called as carboxylate ion. Okay. So this is about the introduction. Now we will study in depth about this. Okay. So I will tell you in board exam how you will write and in question how you will get questions. Okay. First of all, if it is question is there in the exam, why carboxylic acids are acids? Okay, what will be the question? Why carboxylic acids are acidic in nature? Okay, why carboxylic groups are acidic in nature? Are acidic in nature. Okay, so here I will write R C double bond O H. Okay, so here there will be partial positive charge, there will be partial negative charge. Okay, so once it loses, okay, so anything which furnishes H plus, anything which furnishes H plus in the aqueous solution is called as a acid. Now here it is carboxylic acid. In short, I will write as a C acid. Is it okay? Okay, next it is carboxylate ion. What ion? Carboxylate ion. Okay, this ion is called as a carboxylate ion. Okay, RCOO minus. Now this carboxylate ion is stable. Okay, so that means loss of H plus is not making any problem. Okay, like somebody says, if I am not there in company, company is going to ruin, or if I'm not there in this institute and nobody is going to study, like that. Okay, so but there is no problem with the hydrogen. If H plus is completely removed also, still it is able to give you the stable structure. Okay, so what is the resonance structure? See here, R C, and here it is double bond oxygen. Here it is single bond oxygen, negative charge. Okay. Now I think everybody should know the number of electron. Okay. Number of electron on each oxygen. Okay. I am marking it here. Number of lone pair on A and number of lone pair on B of this oxygen and this oxygen. Okay. Who knows it? So here, see, question is very important. Okay, if question is number of lone pair, answer will be different. Okay, number of lone pair electrons is different. Okay, I am receiving. That's why main problem, the way of questioning is important in chemistry. Everybody feels that I have done very correct. Okay, RCOO negative. Oxygen basically will have how many electrons? 6 electrons. Okay. So, but because of this negative charge, there will be one more electron. There will be one more electron. So, lone pair, number of lone pairs. Suppose question is number of lone pair. Here it is 1 and 2 and how many? 3. So, answer number of lone pair on A will be 3 lone pair. If electrons are there, 6 electrons. Is that clear to all of you? A number of lone pair on A are 6 electrons. Lone pair are 3. 3 lone pair are 6 electron. Now we will count out here. See, every oxygen in its valency shell have how many electrons? Very good. 6 electrons. So 1, 2, 3, 4, 5, 6. Now you can identify how many lone pairs are there. I am talking about the B. Lone pairs are 3. Sorry. Lone pairs are 2. Lone pair electrons are 4. Lone pair electrons are how many? 4. Is it clear? I think nobody got any doubt now. Okay. Now this name is called as a carboxylate ion. Which ion? carboxylate ion. Okay, carboxylate ion. Now let us see what is the resonating structure of carboxylate ion. So all of you listen very carefully in the mechanism. Once you start mechanism, that time it should not create any problem. Okay, so here this is the O minus and here it is simple neutral. Okay, so after some time what happens, this lone pair will go and share here, this pi bond will come and share here. Okay, so after that what will happen, this carbon. Okay, now this double bond oxygen will be single bond oxygen, double bond oxygen will be single bond oxygen, and this will be oxygen. Now three lone pair, therefore negative charge, and here single bond oxygen will become as a double bond oxygen and with the two lone pairs. Okay, so this is also carboxylate, this is also carboxylate. Now when you combine both of them, then you will get the hybrid. What you will get? Resonating hybrid you will get. Then I am writing the resonating hybrid. So both places single bond is always there, but double bond is broken line. Double bond is denoted with the, because sometime it may be there, sometime it may not be there. So RCOO, and this will be two negative, sorry, one negative. Very sorry, it should be one negative charge is given, RCOO negative. So that negative you should write over here. Okay, that negative you should write over here. This is a resonating hybrid. Okay, number of resonating forms of carboxylate ion. So most of the students have wrong impression that this is also resonating structure. No, this is not resonating structure. Okay, there are only two resonating structures. There are how many resonating structures? Only two. This is first resonating structure. This is second resonance. Okay, this is not resonating structure. This is the hybrid. Resonance hybrid will always be more stable, will always be what? More stable and less energy. Less energy. Is it understood? So these two are equally stable. These two are equally, identically. What they will use? Either they will use equally or they will use identically. Okay. So that is what the carboxylate ion stability. I think it is clear to all of you now. Okay, now this slide is now absolutely clear, I hope. Okay, if you have any problem, tell to me, then I will explain you. This is one resonating structure, this is another resonating structure, this is resonating hybrid, this is one and this is two. Now let's see the next slide. Okay, up to here there should not be any problem, because after clearing your previous doubts only I am going further. Okay. So I think all doubts are clear. Now let's go for the next one. Okay, next classification. In aldehyde ketone also we have done classification. Okay, so here also again we are doing the classification, but classification on the basis of what? Okay, so classification is on the basis of group to which COOH is attached. Okay, here R is a hydrogen, it can be hydrogen or it can be alkyl, it can be alkyl group also. And here AR can be aromatic. Okay, aryl means aromatic, aromatic means benzene or anything which follows the conditions of aromaticity. Which city? Aromaticity. So if our benzene COH groups attaches to any benzene ring or any aromatic, then they are called as aromatic carboxylic acid. Okay. Suppose benzoic acid is an example. Benzoic acid is an example of aromatic. Propanoic acid. Propanoic acid CH3 CH2 COOH. This is an example of aliphatic. Okay. Now, on the basis of COH group on their molecule, If they contain only one COH group, then it is called as a monocarboxylic. If they contain two COH group, dicarboxylic. If they contain three COH group, then they are called as a tricarboxylic group. Okay, this is based upon the number of, this is based upon the group which COH is attached. Okay. Okay, next one is structure and hybridization. Structure and hybridization of carboxylic group. Okay. See here R C double bond O and this is OH. Okay. So if you compare here, this carbon is connected to three sigma bonds and one pi bond. Three sigma bond and one pi bond it is attached. Okay. So that means we should provide the four unpaired electrons. So carbon it will be 1s2, 2s2, 2p2. Okay. So as of now it is having only two unpaired electrons. How many unpaired electrons are there? Two. Now this electron if it shifts here, then what it will be? 1s2, 2s1 and 2p3. What it is going to be? 2s1 and 2p3. Okay, 2s1 and 2p3. But there is a pi bond here. So for pi bond, we should not use this electron for hybridization. So hybridization will be sp2 hybridization. Why I am not using this? Because this is a pi bond. Always remember, only sigma bond and lone pair will use as the hybridization. Okay, which comes trick. Okay, what is the which came tricks? Simple hybridization. Hybridization, if you wanted to find out, simple lone pair plus sigma bond. Okay, here you can find only three sigma bond, no lone pair is there, so three sigma bond means three hybridization. So sp2 is the answer. What is the answer? sp2. Once it is sp2 hybridization, once it is sp2 hybridization, answer should be structure. What should be the structure? What should be the structure? Triangular planar. Okay. What is the structure? Triangular planar is the structure. Okay. That is what hybridization. Is it clear to all of you? Or should I explain it? Okay. I will explain on the whiteboard. Here, see, this is the carbon and it is attached with the total three groups. Okay. And one group it is double bond oxygen. One group it will be OH. One group it will be OH. Another group it can be R. Okay. So, but when I combine all of them, that will be a, what it will be? A triangle, equilateral triangle, and here bond angle will be 120 degrees the bond angle, and answer shape of the answer will be triangular planar. What is the answer? Triangular planar. Okay. So now I think structure, hybridization, all are clear. Okay. Anyhow, I will write it all together so that it should be easy for reference. Bond angle is 120 degree. Triangular planar hybridization will be sp2. Suppose if you are aspiring for very high level exam, that time they may ask pi bond also. The pi bond is of p pi bond. Okay. What is the answer? P pi bond is the answer. Okay. Okay, now this topic I think it is clear now. Structure and hybridization. Okay. Now coming to the general formula. General formula will be CnH2n. Okay, people study this one as a general formula. CnH2nO2. Okay. This can also be written. Actually, there will be one COH group is must. So if I write as a COH, then it is going to be alkyl group. Alkyl group formula will be CnH2n plus 1. Okay. If it is H2N plus 2, then it will be alkane, alkane. Okay. If it is plus 1, then it will be alkyl. Okay. I am clearly writing it here. CnH2n. If it is plus 1, then it is alkyl group. Okay. So that is what we want. Either you can remember this or you can remember this one. Okay. Now, here, saturated and unsaturated monocarboxylic acid are also called fatty acids. Okay. So, unsaturated means there must be double bond. There must be what? Double bond. Okay. Unsaturated means there should be double bond or triple bond. Now, they are called as a fatty acids. Okay. Why? Because, see, palmitic acid, stearic acid, oleic acid are obtained by the hydrolysis of fats and oils. When oils and fats are treated with the water, we are getting these, okay, and which are used in the soaps also. Soaps uses these acids only, but they uses this salt, okay, palmitic, sodium palmitate, sodium stearate, sodium oleate, okay. So I am writing it here also. Uh, what is that? They are used in the soaps. Okay. In the soaps, what is the name? What is the name? Sodium palmitate. Okay. Sodium palmitate. Okay. Whatever the fat we find in the soaps, that is because of this one only. Okay. Then it will be sodium stearate. Sodium stearate. And then sodium oleate. What is the next one? Sodium oleate. So these are the some salt which are found used in the soaps industry. Okay. Next, what type of isomerism they can show? Chain isomerism, position isomerism, functional and optical isomerism. Already this we have studied in carboxylic group. It is sp2. Okay. What is this? It is sp2 hybridization. Now, first of all, let us see about the chain isomerism. Okay. Now, let's go to the whiteboard and chain isomers you have to write. Okay. So, first of all, in chain isomerism, are you able to see the whiteboard now? All of you are able to see whiteboard? If yes, tell me. Okay, chain isomer starts from. If question is chain isomer of carboxylic acid starts from. If chain isomer of carboxylic acid starts from which number of carbon? Okay, here what you will write? Dash number of carbon atoms. Minimum how many carbon atoms are must? Okay, number of carbon atoms. Who can say after how many carbon atoms there can be chain isomers? For example, what is this HCOOH? Okay, HCOOH name is formic acid. Commercial name is what? Formic acid. Okay, but actual name will be methanol. What? Sorry, methanoic acid. What is its name? Methanoic acid is its name. Next to it cannot show because only one carbon is there. How it can extend or change? Okay, then another acid will be CH3COOH. This will also does not show. Its commercial name will be acetic acid. Commercial name will be what? Acetic acid. Otherwise, its IUPAC name will be ethanoic acid. IUPAC name will be what? Ethanoic acid. Is that clear? So, CH3COOH. Okay. Next, dash number of carbon atoms. What is the answer? So it cannot also show. Let us take CH3, CH2, COOH. Can it show? No, it cannot attach here. It is already attached here. So this is called as a propionoic acid. Propionoic acid. Okay. So it also does not show. and next one will be with 4 carbon. Let us take as a 4 carbon. Okay. Now here fourth carbon can be here and fourth carbon can be straight line. Okay. So this is what COH, butanoic acid, and here 2-methyl propanoic acid. So that means from 4 carbon chain isomers are possible. So answer should be what? What should be the answer? Very good. Few students already sent the reply. From minimum 4 carbon atoms. Okay. Isomerism will start. What is that isomer? Chain isomer. Okay. Okay. These are the some important dicarboxylic acid. Okay. What is the first one? And you should never forget the first one. Oxalic acid. So many times it is coming in the examination, not directly. Either it's use or somewhere preparation, like that indirectly they are asking. Okay, so never forget this one. Oxalic acid is simply 2COH. Here there is a pattern I will tell you. See, all are having 2COH only. Okay, so but in between them what is available, that matters. In between them what is available, that matters. COH. Okay, COH and COH and COH. But here how many carbons are there? Nil carbons are there other than the COH. Here how many carbons are there? One. Here how many carbons? Two. Here how many? Three. Other than the COH I am telling you. And here how many? Four. Here how many? Five. Okay, so to remember this, you will remember as a trick. Okay, so the trick is on the next page. Okay, the trick is on the next page. You will remember ohms. Okay, what you will remember? Ohms gap. Ohms gap. Okay, Ohms gap. O means, here I will write the full name. Only thing, you will keep on adding the number of carbons. Okay, O means what it is? Oxalic acid. O means what? Oxalic acid. Okay, M is what? Malonic acid. M is what? Malonic acid. OMS. Okay, M stands for malonic. Okay, malonic acid. S stands for succinic acid. Okay, SUCCINIC, succinic acid. Okay, G stands for glutaric acid. G stands for glutaric acid. Okay, and A stands for, very important, this is used in the polymerization also. So this is adipic acid. What it is called as? Adipic acid. Oh shit. Okay, here what does it stands for? Adipic. It stands for adipic. Okay, ADIPAC, adipic acid. And P stands for palmaric. Okay, PIMELIC, pimelic acid. So these are the name, and this is the trick to remember them. Ohms gap. Okay, so very important dicarboxylic acid. I think everybody will remember them. Okay, now we will do some questions on the naming. Okay, so that you can have the practice from the basics. Okay, let's go for the questions now. I will write the questions. Okay, here this is very important question. That's why I have to give it to you. There is a new rule implemented in this one. Okay, as per the old rule, this will not be able to solve. Here the main chain is this one only, because if I select this chain, listen carefully. Okay, listen very carefully. If I select this and this and this, if I select this one and this one, then problem, I will not be able to select this one. So the solution is, don't select this one, don't select this one, don't select this one. So if it is consisting on only 3 carbon, so for 3 carbon what we will write? Probe, and between them there is a single bond here, so it will be AN, propane. Okay, And how many COH groups are there? 1, 2 and 3. That's why we will write 1 comma 2 comma 3. See, it is available on first, it is available on second, and it is available on third. So 1, 2, 3. 3 are there, therefore it will be tri. Okay. For the COOH, we will write as a carboxylic acid. What we will write? We will write as a carboxylic acid. Okay. So propane 1, 2, 3 tricarboxylic acid is the name. Propane 1, 2, 3 tricarboxylic acid is the name. Okay. So similar question I will give for practice. If you are able to do that, then nothing is required in aliphatic. Okay. So the next question goes here. So start it very fast. If you got any doubt in this one, you can ask. Okay, here people will get doubt and very nice to see this type of doubts. Okay, see here this carbon, if COH carbon is not included, okay, is not included, is not included in the main chain, included in main chain. Okay, because we are writing probe, that means that carbon is not counted. That time we will write carboxylic. Understood? If it is included, COOH is included. Not included is becoming as a is included. Is included in main chain. Okay, like if it we are counting this one also, then it will be butanoic. That time it will be oic acid. Okay, included in the main chain. If it is included in the main chain, that time suffix will be oic acid. When you will write oic acid, when you will write carboxylic acid, I think it is clear to all of you now. Okay, very wonderful doubt. Because of that, everybody got new information. Okay, so I was thinking that you already know that. So next question I am writing it here. Write it very, very carefully. Okay, COOH, CH2, CH2, then CH, COOH, then CH2COOH. Similar to previous question, if you understand that, you can definitely do this. Okay, see, now I am explaining it with proper explanation so that similar type you should never miss out. Okay, here this is the main chain. Why? Because if I take this and this as a main chain, I will be missing this one. So once you miss any one of them, then you should not consider everybody. Okay. Now here numbering should be done from right to left so that lowest sum rule is followed. What is followed? Lowest sum rule is followed. So on 1 it is COH, on 2 it is COH, on 4 it is COH. Okay. So it will be but single bond N 1, 2, 4. Okay. Butane 1, 2, 4 tri carboxylic acid. What is the answer? Tricarboxylic acid. Okay. So those who are answered like this, congratulations to them. Those who could not answer like this, they are learning something new. Okay. So should I give some complicated questions now? Okay. So very, very carefully write down. Don't miss a single carbon also. Okay. Okay, this is somewhat complicated question, but thinking that once you can do this and you can definitely do this, try and let me know. Okay, I hope you have tried. So this being complicated, first I will give you the hint. Okay, this is the main chain. This is the main chain. Now you can try. Now why it is not considered? Because it is not directly attached to the main chain. Okay, so the numbering will be from here. 1, 2, 3, 4, 5, 6, 7. Okay. So these are the 7 carbon atoms. This will be substitute and this will be substitute. Okay. You can try and let me know. Okay. Very good. This is complex substitute now. Okay. So that bracket 4. Okay. then it will be carboxymethyl. It will be 4-carboxymethyl. This is prefix now. On methyl it is carboxy. That's why it is called as a carboxymethyl. Then it will be ethyl. 4-ethyl. 4-ethyl. Okay, total 6 carbon atoms are there. So hexane 1,6-dioic acid. Now we are using dioic acid because that carbon we have counted here. Okay, so here this COH is already counted here. Dioic acid. Okay, so 4-carboxymethyl 4-ethyl hexane 1,6-dioic acid. Okay, hexane or pentane? Heptane, sorry. Here it is heptane. Okay, seven total 7 carbons are there. Therefore, it will be heptane. Okay, heptane 1,6-dioic acid. Here also mistake 1,7-dioic acid. Okay, so already I have told you Ohm's gap technique, and other than the some commercially important acids, some commercially important acids. Okay, some commercially important acids. Okay, first one CH3 like this, and CH2 16 and COOH are there. Then it is called as a stearic acid. Okay, sodium stearate, it is used in the soaps. Stearic acid, STEA, sorry. STEARIC, stearic acids. Okay, commercially important, but whatever we have studied, okay, whatever we have studied, that is dicarboxylic acid. Okay, and one side it is CHO and another side it is COOH. Then it is called as a glyoxylic acid. Okay, what it is called as a glyoxylic acid. If both are COH, then it is oxalic acid. Okay, but if it is only one side aldehyde, another side carboxyl, then it is called glyoxylic acid. Okay, CH3, CHOH and COOH. It is very important for the optical isomerism. Then it is called as a lactic acid. It is called as lactic acid. Okay, and lactic acid, the main importance is of this carbon. Okay, this carbon is now chiral carbon. What is this? This is chiral carbon. Okay, on chiral carbon, one side it is COH, another side it is H, and another side it is OH, and one side it is CH3. Okay, lactic acid. Then acrylic acid. CH2 double bond CH single bond COOH. Okay. Next CH3 CH double bond CH COOH. 4 carbons are there. Then it is called as a crotonic acid. Crotonic acid. Okay. 4 carbon. If 3 carbons are there, acrylic. ACRYLIC. Acrylic acid. Okay, these are some commercially important carboxylic acid, note down. Okay, after naming isomerism, already I told you chain isomers will start from 4 carbons. Okay, then coming to the other than the chain isomerism, carboxylic acid shows the functional isomerism. Which isomerism? Functional isomerism also. Okay, but functional isomerism will be carboxylic acid, okay, and alkanoic acid. Okay, have functional isomer. These are hydroxycarbonyl compound. Okay, what is that? That I will tell you. Carbonyl compound. Okay, next esters and hydroxyarenes. Okay. Otherwise, simply it is sufficient now. Okay. Oxiranes, hydroxy or oxiranes, hydroxyoxiranes. Okay, so first mainly you should remember this one. Okay, so first of all, let us take CH3 COOH. Okay, this can be written as CH2OH and CHO. See here, both are having two carbon atoms and both are having three hydrogen atoms. Okay, sorry, four hydrogen atoms and two oxygen. Okay, this is carboxylic acid, this is hydroxycarbonyl. This is hydroxy, this is carbonyl compound. Okay, next, suppose CH3 CH2 COOH can also be written as CH3 COO CH3. Okay, so that means we can write it as a ester also. Functional isomer of carboxylic acids are esters also. Okay, question is write all functional isomers of ethanoic acid. Okay, ethanoic acid, I think everybody know. Acetic acid is also called as ethanoic acid. CH3COOH. You can try, otherwise I will tell you. Okay, see, all carboxylic acid shows the three types of functional isomers. First one is hydroxycarbonyl. Hydroxy, this one, carbonyl means aldehyde. So its IUPAC name will be 2-hydroxy. Numbering will be from here to here. It will be 2-hydroxyethanol. What it is? It is 2-hydroxyethanol. Okay, now it is clear, I think. Ester also, see here. This is written first in the ester naming, methyl, and it is methanoate. Understood? And oxirane means this functional group is called as oxirane. On this, it is on the second, sorry, 1-hydroxy. Numbering will be done 2. Okay, so 2-hydroxy organic, this oxirane naming will be from the oxygen, so 1 comma 2, so 2-hydroxy oxirane. Okay, these are the functional isomers. Okay, so these are the things we have done. What are the things we have done? Name, structure and hybridization of carboxyl we have done. One reasoning question we have done, and position everybody can do, optical everybody can do, chain isomer everybody can do. I felt that you require some practice in functional group, that's why I have given you special training in the functional group. Okay, so in this naming of the dicarboxylic, naming of dicarboxylic acid is very important. What is the rule? Ohm's gap. Okay. Other than that, some commercially important also I have given. You go through that. Understood? So these are the very important topics. I think now it is clear to everybody. Okay.